Hello, I'm Paul Beckwith. I'm with the University of Ottawa Laboratory for Paleoclimatology. For many years, I've been talking about abrupt climate change and how the climate system is no longer behaving like it used to. We no longer have the stable, predictable system that we had. We've gone to a chaotic system. As we transition in a nonlinear fashion to a much warmer world, we're seeing a complete redistribution of jet streams and ocean currents. So normally we have jet streams in the northern hemisphere and in the southern hemisphere, and they go mostly from west to east. But because the Arctic is warming so much, because it's getting darker, it's absorbing more solar energy, there's great temperature amplification, then the jet stream has been slowing down and is getting wavier. So there's more troughs and there's more crests. And basically, think of it as separating, the jet stream is separating the cold dry air from the northern regions and warm, moist air from more southerly regions. But in this case, you normally have jet streams in the northern and some southern hemisphere, but they're separate. But in this case, we can see the jet stream twisting down here, crossing the equator and rejoining the stream in the southern hemisphere. You can also see it here, and you can also see it here. This is new as far as I'm aware. Normally the equator is hotter, so there's a ridge. The air rises up high, hot air rises. The tropopause is about 17 kilometers, whereas the colder air means that the tropopause is about 7 kilometers at the poles. So because it's so high here, normally that acts as a barrier and it stops this from happening. So let's investigate why this is actually happening. I just shut the lights off for better contrast. So if you just Google Earth Null School, go down, click on Earth, and then select air, 250 millibar pressure, and the wind overlay, then this is what you get. Click on Earth again to get rid of the menu. This is what you get, and focus on this green area here. If you click on other areas, it gives you information. It tells you the speed. So the pink areas, purple areas are faster jet streams. But we're seeing a crossing here, here, and over here of the equator. I was alerted to this by Robert Scribbler's blog, which just came out this evening. He's talking about wrecked jet stream now runs from pole to pole. So he showed this still image here, which alerted me to do this video. So I'll talk about some of the things that he was saying again in a minute. So let's go back. So what I've done here is I've selected the temperature instead of the winds here. And so this is the temperature. So you can see this is temperature at 250 millibar. It's high up. So this region is about -40. When you go into this region, it's colder, about -53. And in the blue region, it gets even colder. So this is up in the atmosphere. But what you can see is that the jet streams are actually acting as like a wall or a separation between the air of different temperatures. Wherever there's warmer air in this case, and you get a curve of the jet stream around it. I just wanted to point that out. Now this is sea surface temperature anomaly. So the circle, the green circle, is where the jet stream is coming down and crossing the equator. It's interesting to note that this area of water, because of the El Nino, the strong El Nino has passed, we're getting a cooling of this water as we head towards a La Nina. And so this cooling of the water is lowering that pressure ridge, that high pressure ridge that is normally at the equator. And the water is anomalously hot here and here. So it's bringing up the pressures here and here. It's lowering the ridge, if you like, allowing, and I think that may be contributing to allowing air to cross the equator here in the jet streams. If we look at the temperature, this is the ocean water temperature, you can see that here it's about 24.5 degrees, and as we go here it's about 30, and as we go down here it's approaching 30 numbers. Okay, so the waters, so we've got this pocket of colder region at the equator, so this lowers the barrier which normally stops the jet stream from transversing from one hemisphere to another. So if we go back here, I have shifted this data. I've shifted the map along. If you select E, you get this this particular distribution, whereas O would be the globe. Okay, so I wanted to go back here, and now this is present time, and what I can do is I can go back a day and see how long has this thing been developing for, how long has this thing lasted for. So let's bring this over here so you can see this because it's not blocked by the menu, and I'll go back a day and you can see it's there but it's much weaker. I'll go back another day, and now it's pretty much broken, it's pretty much gone. I can go forward 3 hours, it's still separated. I can go forward 3 more hours, still separated. 3 more hours, it's starting to get closer here, the gap is narrowing. And if I go back 3 more hours, it seems to be forming here. So basically June 27th, 11 a.m. local time is when the breach, if you like, was broken, the equatorial breach, and the jet stream then started passing through. This is another view of this particular region, and again you can see you can see what's going on here. You get air from up high in the northern hemisphere in this jet coming down and crossing the equator and then joining with the southernmost jet stream. You also have these vortices here which are mixing air around the equator. You have air actually moving from the southern hemisphere up into the northern hemisphere across the equator here, and over here you have air coming south and coming across. And over here you have a similar thing happening. So we've lost this separation between the northern and southern hemisphere in terms of the jet stream. So let's have a look, let's go back to our Central Pacific image here. Over here we want to be. Okay. So let's have a look at the progression in time on this view here. So I'll bring up the menu and let's go back a day. So it's still occurring, slightly different location, back another day, and it's broken up. And you can see that even though this is broken up here, there's other regions where there's air exchange across the equator. For example, here and over here, there's a lot of movement parallel to the equator and then dipping down here. So let's go back to our original region in the Pacific. Like I say, I've never seen this happening before. I've talked in the past about how the jet stream waviness, the Arctic temperature amplification, is causing the jet stream waviness, and when it's much more wavier, it means colder air penetrates to lower latitudes in the northern hemisphere, warmer air moves from the equator up into much higher latitudes, so it tends to lead to an equalization of temperature in the northern hemisphere. Now what we're seeing is if this becomes a pronounced feature where the jet stream actually crosses into the southern hemisphere, then that will basically help to an equalization of the entire global temperature. So it will reduce seasonality, as Robert Scribbler has pointed out, if it becomes a constant feature. So I just want to show you ocean sea surface temperature anomaly. Okay, so this is where this whole region here, the temperature is much cooler than normal. This here and here, it's warmer than normal. That leads to a sea surface temperature cooler here, 24 degrees, and warmer here and here, significantly warmer. And that tends to have lowered the, so that would lower the tropopause, the height of the troposphere above this point, and it would raise it up here. And obviously that's enough to carry these high altitude winds clear across the equator. So going back to Scribbler's blog, he posted an image here, and it shows basically, don't worry too much. This is zonal wind anomaly, and this is 1 sigma above normal, 1 sigma below, and so on. So we went from a record height, a record max excursion in the positive direction to almost a record minimum in the negative direction. What is MQI phase? So what this is the MQI index it's an index. There's something called the QBO, or quasi-biennial oscillation, and I'll explain what that is quickly because you need to know. So it's a way of monitoring the winds, the equatorial stratospheric zonal winds, so zonal west to east, east to west. So as you go through from December of 2014 to December of 2015, that's about half of a cycle. So another year would take you around. So this is why it's called quasi-biennial QBO oscillation. So you get a change in the direction of the wind. So these are the wind maximum is in a westerly direction at 30 millibar. Here it's in a westerly direction at 50 millibar. And as you go down to different times of the year, it goes to the east. So the wind direction switches in the stratosphere at the equator. That's what this effect is. This plot was generated in November 2015 and projected that the QBO would just continue along here as normal. This is what's actually happened. So this is what's actually happened is that, I bring this over? Not really. Instead of proceeding around in the circle, it's now dropping to record minimum levels. So there's very strange things going on planet Earth right now. There's very, very strange things going on with the jet streams which guide our weather patterns. We're seeing, this is an exceptional year in terms of Arctic sea ice melt and snow cover loss in June. We're pushing along the record low amounts of sea ice. The ice is getting darker, it's getting broken up. The Arctic temperature anomaly has been very, very large, and as a result, there is a risk of going to a blue ocean event this summer, in which case towards the end of mid-September, we could expect very low sea ice, probably a record for sure. And this is leading to much greater warming of the Arctic, much more waviness of the jet streams. And when you combine it with the very strong El Nino and then the cooler La Nina waters here, we're seeing a breach of the equator and the jet stream is crossing clear across. I can't stress how important this is to the climate system. You can watch some of my other videos to see my reasoning, but we need to declare a climate change emergency. We're going to have massive hits to the food supply. We're going to have massive geopolitical unrest. We're already seeing things like that happening around the world.